Nesh Bala. I'm with Security Compass. Before I begin, I want to thank Hack in the Box and Dylan and his crew for organizing this awesome event. I know 2 days, lots of information. You must be overloaded. 2 more hours to go, and then we'll all go drinking, right? So today I am going to be focusing on how to perform code reviews of large code bases. Recently, organizations have been heading in that direction, and over the past few years I have been doing code reviews, and the focus has been from small applications to large applications, and how I went about doing it, and have tried to come up with a methodology which I'm trying to share with you over here. It is nothing dynamically new. It's probably a lot of what you have already read, but I've tried to compile it together, what we do on a day-to-day basis. Okay, what will I cover? A little background on performing code reviews. We'll talk about our methodology, which is broken into 3 major components. There's the threat analysis. The next portion will be we'll be assigning value to the threat, how to assign value to the threat. The purpose of this technique is basically, without having a proper value to the threat, do you want to actually go to the code level and review that part of the code? And then lastly, we'll be doing common list of issues. Here I'll be focusing on C, C++, and this portion will be very, very interactive. I'll be presenting some code. Hopefully you'll tell me what the bug is, and for every positive answer, there'll probably be a giveaway. Okay, let's get into it right away. Defense in depth in the past and present. We used to have firewalls. That's where everyone started. First, the internet was, nice, friendly place. Everyone had no firewalls. You remember the movie War Games? Machines open, you just did research a little bit about a company or whoever wrote the application, and you would be able to probably break into the application by just guessing the person's last name or child's name. Like in War Games, you had Joshua, right? So that was the past, and then companies started putting up firewalls to protect their environment so that people from the outside did not break into the network. Then came the separation of networks, because now that the firewalls were there, they had employees who were still breaking into the network, so they wanted to separate the critical data, and they started separating the network so that the employees did not break into the network, and they had a DMZ zone. Then came network and host assessments, where everyone wanted to get their critical servers assessed, and also try to build bastion hosts or hardened hosts. I'm sure all of you security people and administrators and pretty much everyone in this crowd has every machine on their server environment which is totally hardened, right? And then came more managed vulnerability scanning, and lastly, and lately over the past few years, people have been doing a lot of product reviews and code reviews. The actual application assessment. And today, over here, we are going to be talking purely about code review. I just wanted to give you the past. The automated tools were RATs, simple static analysis tools, ITS4, and other scripts. People still use it, we still use it, but false positive rates are really high. Compile time and runtime tools that exist today. Ounce Labs has one, Secure Software, and a whole bunch of GCC patches that are available. People use that. We're not going to talk about those over here. What we are going to talk about is manual auditing and small code bases. We're not going to cover that over here, because typically small code bases, there is no problem in reviewing code. If you have 100, 200 lines of code, 300 lines of code, okay. You can read it, one person can read it, understand what is going on, and possibly find all the bugs. Okay? But the problem is generally when you have 100,000 lines of code, how are you going to review it? You get the best developers from whatever country, put them in one room and try to get it reviewed. are you still going to find all the bugs? Is there going to be or they're not going to find all the bugs? Is there a systematic way to go down that path? And that's what we are going to talk about. Okay, what's the methodology? The first part, we'll talk about threat modeling. Again, this is not going to be an in-depth threat model. We're not going to take a model and actually explain it like Peter did yesterday. I don't want to go to that level. I'll be talking at a much higher level. Then we'll talk about what the next step should be. Once a person starts code review, what is all the steps involved? First thing we talk about is, we're going to cover is threat model. Then we're going to talk about everyone should do a cursory code review. As in, if you have 10 developers reviewing 100,000 lines of code, there needs to be a short period of time where they understand the overall application, which they would probably at a threat analysis stage, but they also need to look at the entire code very quickly. Don't need to read the code to understand it, but have a good feeling of what code is being called. Okay, the overall time spent on that, in my opinion, should be no more than 5%. Okay, a couple of days, maybe if it is a month's project. Separation of code. Now that you have 10 people reviewing these 100,000 lines of code, you need to separate the code in proper chunks. How do you separate the code? How do you decide who's going to do what? And what about the overlapping? We'll talk a little bit about that. Maintain code notes. You always want to maintain code notes. I'm sure all of you, just like me, love to read code and document and write reports at the end of whatever projects you do, right? So the ideal thing is always make notes, and next to the note, put the developer should, or the reviewer should put his nickname or his name, so that later on you can just grep for that, dump it in the report, and you have at least a log file. Then you know what you have done and what you have not done, right? Or if someone is looking for some comments that he would have put in, he knows exactly. It's a quick and easy way to go back to the code what you're looking for. Okay, and then do detailed code analysis. That is the stage where detailed code analysis would come. So most of the time, what people do not do is go through the first 4 steps, and what ends up happening is you go to a company A hires you, 10 people, okay, go ahead, do code review, okay, what does the product do? They'll probably spend a day, maybe 2 days. They'll say, okay, our developer team or project manager will have access, you all will have access to them, they will have access to you, but generally there is not a whole lot of interaction. But in my opinion, if we spend a lot of time understanding the first stage, threat analysis, do that properly, do proper separation of code, the person understands, before anyone goes in, he understands the entire application, as well as does a high-level code review. That would help. And then finally, when he's getting into this stage, before he actually starts doing the code review, you need a common list of what is going to be reviewed. Okay? If you do not have the common list, 10 developers, one's a game programmer, one's an OS programmer, one's a driver programmer, they all have their own little niches, right? They are specialized in some particular area. You need to get all that knowledge together, a common area, so that everyone is looking at the same set of vulnerabilities that might exist. Okay, threat analysis. Overview, we'll do a quick overview. We'll talk about what is threat analysis, when do you do it, why, who, how. And the how part is, again, the part that is going to take most of your time in this part of the code analysis. Okay? We'll then talk about common list of issues in C++. These are just the very basic ones. I am not going into detail. Obviously, there are tons of them. Hopefully, Security Compass will be releasing a document later this year. We are working on one. We'll release it out to the public, and you can check it out. The ones we will cover are termination related, validation, and calculation. A lot of these you would have already seen which have led to buffer overflows. Nothing really exciting. And this portion, however, I would like you all to definitely talk back. Okay? Okay, let's get right into it. Threat analysis. What is threat modeling? attacks against an application. Okay. Threat modeling is basically when a developer, and threat modeling has been existent for the longest time. In today's world, security companies, big security companies have come up with the word threat modeling, but earlier all the buffer overflow writers or developers, when they used to brainstorm together, that's what they would come up with, finding bugs, right? That's what it is. Okay, why threat model? The important fact, when you get into, again, 100,000 lines of code, where are you going to focus? Where are you going to put your energy to look at code? You can't look at the entire code base. You have to choose which areas you're going to cover. And you want to actually assign value to each major area. That's what is important. Once you have an assigned value, you put in some kind of number, then you say, okay, from this entire code base, every entry point or every place where authentication is taking place, that's the major area. I'm going to give it more value, and then that code has to be reviewed. Okay? Who should be involved in threat modeling? In my opinion, every single person involved with the development, project management, and business needs to be involved in threat modeling. Why is that? Because the business, first of all, most of the times the applications are always required yesterday. And then you get the request for developing the applications. So in a lot of times, developers are not alone to blame for vulnerabilities that exist in applications. The business needs the application yesterday, or how many of us know of an intranet application that was purely developed for the intranet suddenly available on the internet? I'm sure all of you have at least encountered one of those. So always, always know your entire environment and have all the people that you think need to be involved at any stage in discussion over here. And most importantly, have someone from security who has background who can actually discuss the possible problems with the application. When should you threat model? There are at least a couple of stages when you should threat model. One is once you have enough time you want to threat model. The second thing is once you have an application somewhat developed before it goes to even testers, then you should threat model. And lastly is after the entire testing has been done, you want to threat model. If there are any changes made to the application, you must threat model again. Why do you want to threat model at all these stages? The reason to threat model at all these stages is at every stage the application changes. When you are in the design phase, your application focus might be completely different. By the time you are in pre-production or just in the stage of an alpha release, your application might have already changed. The focus of the application might have changed. The technology might have changed completely. So you want to threat model again and figure out where your application is focused and go back and see if there were any things that were missed out. Okay, when do you typically threat model? Never. Most organizations don't threat model at all. In the stage of an alpha release, your application might have already changed. The focus of the application might have changed. The technology might have changed completely. So you want to threat model again and figure out where your application is focused and go back and see if there were any things that were missed out. Okay, when do you typically threat model? Never. Most organizations don't threat model at all. Or it's performed after application is vulnerable. A lot of applications have been threat modeled after the application is vulnerable. At the same time where an attacker has also threat modeled or has figured out what the major entry points are and is trying to attack. You as a developer or as a program manager should have threat modeled that application before it was released. If it is already released, you should threat model immediately, as soon as you can. Okay. Here's a waterfall model, the old SDLC technique. This has, of course, been updated more recently. Microsoft has released a different model that they use, which is also pretty interesting and definitely worth looking at. The green points are where typically you should threat model, and the red arrow is where typically threat modeling takes place. You should try and threat model right after the program design and right before. Again, if there is any change to your application, threat model again. So we have covered what is, when is, why, and who to threat model. Now we're going to talk about threat analysis from the high level. Okay. Step one, it's a process. It's a three-stage process, and the first step is collecting information about the application. That's pretty standard. You have an application, you want to get as much information about it, the background information, what operating system it's going to be installed on, why it was built, who is going to build it, if it was an old version, if you're doing any kind of upgrades, what's the focus of the new upgrades, and so on. Then you want to break the application down into major chunks. Okay. Here in this part, we'll talk a little bit about what Microsoft recommends, and then I've been trying to come up with a technique which I've been using in doing code reviews, and then I'll present that as well. Then we'll talk about analysis on determining the threats itself. What does this involve? We'll do a quick walkthrough of different locations where issues could occur. And then we take C++ code and we actually do the walkthrough as well. Okay, step one, collecting background information. Any dependencies that exist, local, remote, versions, maybe you need backward compatibility, which has been a problem for a lot of applications, servers, and operating systems as well. Decomposing the application. You can do one of two techniques. You can either break it through application architecture. What is involved in an application architecture? Authentication, authorization, input validation. You know the standard stuff we talk about when we are talking about any application. That's what we'll talk about. And individual components, this is the technique that Microsoft recommends. You have every entry point, every trust point identified, and then focus it on that basis. So in my opinion, you can do it either one of these two ways, but the ideal technique is to combine the two. First, let's look at what Microsoft recommends. Identify entry points, all the entry points, whether they're local, their network, or any other, through file, registry, input, user input, anything of that sort. And then you identify where the trust boundaries are, which is great. You have this information and then you can break the application down. But how are you going to go back to the code and look at that code? The other thing that you can do is you'll have to draw DFD diagrams on the basis of these entry points and also break it down to each level and then figure out where the entry points are. However, what I suggest is you break the application down into authentication, authorization, user management, cryptography, data validation, and event logging, and each one of those you identify the entry point and trust level. Why do you want to do that? When someone is reviewing the code, if he knows if there is an entry point and it is authentication, when we go to the risk section, identifying the value, over there we'll be able to say it is a higher risk if an application requires authentication. Okay, and it is obviously an entry point of some kind, either through a smart card, either through a file or user input. So the chances, and if this application is available on the internet, right? Suddenly the risk level has increased. Whereas if this application is on the intranet or in DMZ, it's not that critical. So we identify the threats. Now, after we have identified the threats, then you do your standard, you figure out what analysis to be done on the threats. Okay? What are threats and vulnerabilities? What's the difference between threat and vulnerability? Threat is something that could exist, whereas vulnerability is something that is susceptible to an attack, right? Okay, now that we have done all this, let's talk about assigning value to all these threats that exist in the application. The typical DREAD model that Microsoft recommends, go through all these, try to assign a value, divide them by 5, you get a value, and then you decide whether to review code or not. Little complex. In my case, what I suggest is you have authentication, the list that I have provided, and you have just 3 values, low, medium, or high. For low, you just assign 1, 2, and 3. How do you determine whether it is low? If it is on the intranet, maybe medium. If it is internet, non-critical, no PII, static HTML pages, or a typical application that is not going to be vulnerable to any attacks, okay? And high, it holds critical data, like you have your terminal server available on the internet, or if you have an application like bankers app, your online banking, if it is available on the internet. So once you have identified that, each one of the authentication authorizations, you put value to it, 1, 2, or 3, total it up, and then if it is less than 8 overall, you assign it as low risk. You don't have to really review that portion of the walkthrough on threat analysis and how to assign value to it. Are there any questions on this part before I get? Are there any questions on this part before I get into the actual code itself? Okay, great. So how do you review code? We have already talked about threat analysis. Everyone should read the code. We talked about breaking code into separate chunks. Then you obviously maintain code nodes, and then you do detailed code analysis. Now we are going to talk about a common list of issues that would exist in C, C++ applications. Let's jump right into it. There are 3 major areas that we are going to cover today: termination issues, validation issues, and calculation issues. In termination, we will talk about null termination and Sterling, conditional termination, and premature termination. Can anyone tell me what the problem with this piece of code is? For a piece of chocolate. There's a hint about the Sterling. Go ahead, sir. That is correct. Here you go. So, it's a very simple, basic problem that we still see today. The problem is Sterling. What happens with Sterling? Sterling returns the length of the string, excluding the terminating null. So you forgot to put +1, a simple +1, and it can. So what will happen when you actually go through that piece of code? It is going to look for null and it will keep going. And you could lead to a buffer overflow over there. Okay. What about this piece of code? We have a while statement. It says index is less than buffer length, whose size is 20, and buffer index equal to not equal to null. Any guesses? Come on, guys. Less than or equal to, somewhat close. It's the logic error. It's the old logic error. What would happen if it is 5? It is still going to fall through, but then string length, it's still going to go through, and it's actually going to have the value. String length is going to have the value of 5. You need to properly put braces around it. Index ++, this value is going to be incremented or not if it fails. Because if index is less than buffer length, which let's say 5, it's going to fall through this. Index is not going to be incremented, and string length is going to still be 5. So that's a problem there. Next one. This is a simple bug. So we have int a equals 1, semicolon. Anybody? Yeah. It's never going to execute. It's going to terminate the statement. There you go, sir. Oh, sorry. So, validation of, let's go into validation. The exported functions, command line, and string formatting. Again, this is the good old days, right? Hopefully we never find this bug. Yeah, buffer overflow, the standard buffer overflow, the stir copy. That is always going to come back and bite us in the behind. What about this? Look at the size of buff. Reading too much. We have 5,000 coming in, and we are just allocating 2,000. And what's going to happen? It's going to just override it, cause a simple buffer overflow again. Oops. Let's see. Okay. Yeah, let's go ahead. This one, I guess, I forgot to change the slide order, so the solution is available. It's a simple export of the function. It is reading in 2 arguments, right? File name and size of file name. We know max path is always by standard 260, but if you give it more than that, it's going to corrupt the data. So I guess I get to keep the chocolate for this one. What about this one? This is the old print related issues. You can take the hint from right on top, string formatting. Format string overflow. Who said it? There you go, sir. It's the very old one. It still exists. It's surprising how many times you actually find this piece of code. You find someone doing this. It's generally there for debugging. You leave it there and you forget about it. And suddenly it comes back and bites you in the behind. Okay, calculation. Division. Again, this is something that was, I guess, more recently, in the past 2-3 years, this has got a lot of focus. We have y equals 4096 divided by x, divided by size of long. And what is the value of x? It is received from command line. What is the lowest value x can have? Divide by 0 error. Absolutely correct. Who was that, sir? Okay. So if it is either 1, 2, or 3, you're going to get division errors. And fortunately, the more recent compilers actually will warn you way before. At least VC++ 7.1 does it. I checked it last. I don't know about the other ones. Okay. Okay, here's another piece of code. What is the max size of uint? And what happens with size then? So we are putting size as uint, right? What is unsigned integer? If it is short, it is minus 32 something to plus 32 something, right? What would happen if you put the max size in size? Anyone else? Any takers? If you multiply it, you will have a integer overflow. Yeah, absolutely correct. Sorry, did you say that earlier? It was you who said it. No worries. That's why it's here. So again, same standard problem. Calculation issues. Integer, signed issues, You have to know why and when to assign a value, especially when you're doing some kind of a loop. Okay, again, what happens if you provide max int plus 1? What is max int plus 1 over here? Sorry? I didn't get you. Yeah, it's going to roll around and it's going to cause a problem. Sorry, I was going to keep your chocolate and eat it. Here you go. Okay, last one. Actually, there are a couple more. This is the more Windows multi-byte to wide character implementation. Rather, this is not Windows, I meant Unicode related issues. What is size of 2 data? 2 data is assigned 10, right? But what is that white char, W char? 2. 2 times 10. So what should be the fix for it? You got it partially, right? The fix for it is pretty simple. You need to always be sure that you do size of 2 data, you divide it by the size of whatever type you're using. Okay, it's that simple, but I think, if I'm not mistaken. Okay, here are some simple off by one or few problems. What is it trying to do over here? Char buff max path, buff size of buff equals 0. What would happen? Oh, shoot. Okay, let's see about this one. I guess I joined the 2 lines, but look at the semicolon and just figure out. Int buff of size for j equals 0, j is less than size j plus plus. It's not. Okay, that was pretty much the entire methodology and the high level overview of how to go about doing the code review. Any questions for you? For me, rather. Or for you guys? Yes, sir. His question is, do I use any formalized threat modeling methodologies? The only threat modeling methodology that I use is pretty much sit with the developers and brainstorm with them, try to put it down on paper, and then go back and try to break the code on the basis of that. There is no, most of the times the developers and project managers do not have enough time to sit with you and go through with you in detail. You'll get stacks of documentation which you can sit and read till whenever, or you can do a lot of brain dump and talk to the testers. That also helps out a lot. If you talk to the testers or you ask them point blank, where do you think the problems are going to reside? And most of the times, because you have already done the NDA and all that stuff, they're more than happy to talk to you about it. They don't have a problem. Because as you'll realize when you're doing code review, most of the developers don't want to see their product being hacked, right? Any other questions? Yes, sir.
Any advice, any automated tool to make this process easier?
Can I advise of any automated tool? I think with the VC VC 7.1, they've come out with some part of analysis tool. I guess Tony should be able to answer that.
Yeah, Visual Studio 2005 has prefix and does a static code analysis, and then app verify, which is file fuzzing.
Right.
Stuff. Not necessarily done modeling part, but static code analysis.
How many percent do you think will go?
Depends on how good your code is at stuff.
So I guess what Tony said was it's VC 2005, the beta version, I guess that was being handed out, has static code analysis over there. Ounce Labs has come up with a product that's supposed to be doing it at compile time, and Secure Software, and there are 2-3 other companies that are coming up. But all these products are in, though they're being released and people are purchasing them, in my opinion, still in alpha stage because they're still getting their groove in. Any other questions? Great. Thank you very much for coming. I will see you guys again.